Hello and welcome to Astronomy Daily, the podcast that brings you the biggest news from across the cosmos. I'm Avery.
And I'm Anna. It's great to have you with us. Today we're marking our calendars for a celestial event that will be seen by billions.
That's right. We'll also be diving into a major cosmic puzzle, the Hubble Tension, and how some brilliant astronomers are trying to solve it.
Then we'll come back a little closer to home to talk about Canada's plans to send its very first rover to the moon. And finally, a truly inspiring story about how an amateur astronomer made a cosmic discovery from his own backyard.
It's a packed show, so let's get started. First up, Anna, tell us about this massive event we should all be looking forward to.
Certainly. Everyone should circle September 7th and 8th, 2025 on their calendars. On those dates, we're going to be treated to a total lunar eclipse, also known as a blood moon.
And this isn't just any eclipse. The visibility for this one is incredible. We're talking over 7 billion people across Australia, Asia, Africa, and Europe will have a chance to see it. It's a truly global event.
Exactly. For those who might be new to this, a total lunar eclipse happens when the Earth passes directly between the sun and the moon, casting a shadow on the lunar surface.
And the blood moon nickname comes from that amazing reddish color the moon takes on, right? It always looks so dramatic.
It does, and there's some beautiful physics behind it. As sunlight passes through Earth's atmosphere, the atmosphere scatters the blue light but allows red light to pass through and reach the moon. Essentially, the moon is being illuminated by all of the sunrises and sunsets happening on Earth at that moment.
That's such a poetic way to think about it. So, how long will we get to enjoy this spectacle?
The entire event, from the moment the Earth's shadow first touches the moon until it leaves, will last about 5.5 hours. The most spectacular part, the totality, when the moon is fully in shadow, will last for an impressive 1 hour and 22 minutes.
Plenty of time to get outside and take a look. And as if that wasn't enough, there's another eclipse happening right after this, isn't there?
Yes, just a couple of weeks later on September 21st, 2025. This time, it's a partial solar eclipse, where the moon will pass in front of the sun, but won't cover it completely. This one will be visible from New Zealand, Antarctica, and parts of Australia. So it's a busy month for sky watchers in the southern hemisphere.
Fantastic. Well, from one cosmic measurement to another, let's talk about the expansion of the universe. This has been a source of some major debate in astronomy, right, Anna?
A huge debate. It's a problem known as the Hubble Tension. Put simply, different methods for measuring how fast the universe is expanding are giving us different answers. And the difference is significant enough that it can't be easily dismissed.
So you have one group measuring the expansion based on the early universe, like the cosmic microwave background, and another group measuring it based on objects in the more modern universe, like supernovae, and their numbers don't match.
Precisely. This discrepancy could mean one of two things. Either our measurements are wrong, or our fundamental understanding of physics is incomplete. Now, a team of Indian astronomers, led by Professor Anupam Bhartaja, has introduced a new method that could help settle the debate.
And what's their new secret weapon?
They're using a specific type of star called Mira variables. These are old, pulsating red giant stars that have a very predictable relationship between their pulsation period and their intrinsic brightness. By measuring how bright they appear from Earth, we can calculate their distance with great accuracy.
So it's another standard candle like the supernovae we use, but a totally different type of object. That's a great way to double-check our results. And what did they find?
Using data from the Gaia Space Telescope, they've managed to calculate the Hubble constant, that's the rate of expansion, with a precision of 3.7%. Their measurement aligns more closely with the values from other modern universe observations, like those using supernovae.
So this strengthens the case that the discrepancy isn't just a measurement error. The Hubble tension might be real, and that means what?
It could point to new physics, something we don't yet understand about the universe. It could affect our calculations for the age and size of the universe and deepen the mystery of dark energy. This discovery is a significant step in refining our cosmic yardstick.
Incredible work. From the edge of the universe, let's bring it back to our own cosmic neighborhood. We're heading back to the moon, and Canada is building the ride.
That's right. As part of the Artemis program, the company Canadensis Aerospace is developing Canada's very first lunar rover. It's a hugely exciting project, scheduled for launch in 2029.
It's a compact little explorer, too, only about 35 kilograms. So, what's its mission? What will it be looking for?
The rover is headed to the moon's south polar region, which is a key area of interest for scientists. Its primary mission is to search for water ice. Finding accessible water ice is considered the holy grail for future lunar exploration.
Because if you have water, you have drinking water for astronauts, you can grow plants, and you can even split the H2O into hydrogen and oxygen to make rocket fuel. It would be a total game changer for establishing a long-term presence on the moon.
Exactly. The rover also has a second objective, to measure lunar radiation. Understanding the radiation environment is critical for ensuring the safety of future astronauts. But it's not going to be an easy job. The lunar surface is incredibly hostile.
I'll say, the temperature swings are mind-boggling. The rover has to be built to withstand everything from minus 200 degrees Celsius in the shadows to a boiling 100 degrees Celsius in direct sunlight.
And then there's the lunar regolith, that fine, abrasive dust that gets into everything. Navigating through it is a major engineering challenge. It's a testament to the team at Canadensis that they're taking this on.
Absolutely. We'll be cheering it on in 2029. Now, for our final story, we're celebrating a different kind of explorer, one without $1 billion budget, but with just as much passion.
This is a wonderful story that really highlights the incredible contributions of amateur astronomers. It comes from Switzerland, where an amateur named Josef Kayser has discovered a small moon orbiting an asteroid.
That's amazing. How on earth does an amateur astronomer spot something like that? Asteroids are tiny, and a moon orbiting one would be even smaller.
He used a very clever technique called stellar occultation. This is when an object, in this case the asteroid, passes in front of a distant star, temporarily blocking its light.
Right, so he was watching the star, expecting it to blink out for a moment as the main asteroid, named 2001 PE40, passed by.
Exactly. But what he observed was something unexpected. After the main asteroid passed and the star's light returned, it disappeared a second time, very briefly. That second blink was caused by a smaller object trailing the asteroid, its own tiny moon.
That is brilliant. What a moment that must have been, realizing what he'd seen. Do we know anything about the size of these objects?
We do. The main asteroid is about 12.6 kilometers long. Its newly discovered moon is about 2.9 kilometers long and orbits at a distance of just under 24 kilometers. It's a significant find and a huge achievement for amateur astronomy.
It really is. It goes to show that you don't need to be a professional with a giant observatory to make a real contribution to science. All you need is patience, skill, and a clear night sky.
A perfect story to end on. And that brings us to the close of another episode of Astronomy Daily.
We covered a lot of ground today, from a future blood moon for billions, to a new way of measuring our expanding universe, to Canada's future lunar rover, and a fantastic discovery by an amateur astronomer.
Thank you so much for joining us. We hope you'll subscribe to the podcast so you don't miss an episode. And please visit our website at astronomydaily.io for even more news and all our back episodes.
Until next time, this has been Avery.
And Anna, keep looking up.